Hi, this instructional video is about rewriting an expression into a standard form. This time involving division. For example, we have square root of 10 over square root of 10 minus the I. You see, this is a double whammy. We know in a rational expression, you cannot have a square root on the bottom of a quotient. And definitely you cannot have a complex number on the bottom. Okay? Otherwise there will be no real solution. Undefined, that is. So to simplify that and change it into a rational expression, we're going to multiply to the top and bottom of this quotient by the conjugate of the denominator binomial. So the conjugate is actually negative 10, not a minus anymore. It has to be plus I. And whatever you multiply downstairs, you have to multiply it upstairs. It's an identity. Okay? So by doing so, we have to perform a distributive property. So here we go. Negative 10 times negative 10. You know negative 10 times a negative 10 is simply square root of 100, which comes out as a 10. So that's going to be a 10. And then square root of 10 times I, well, that's I square root of 10. Now the bottom, we have two binomials, so we're going to do the FOIL method on this one. So we're going to multiply the first terms of the binomials. So square root of 10, we already did that. That's a 10. Now square root of 10 times I, that is positive I square root of 10. Its conjugate, which is going to make the middle term cancel, well, this will becomes negative I square root of 10. And negative times a positive I is going to be negative I squared. Now remember, the I was defined as a square root of negative 1. And that means I squared simply becomes negative 1. Okay? So that means right here, since we have minus I squared, in fact it means negative times the quantity of negative 1, which becomes plus 1. So let's simplify right here simultaneously. The conjugate, the middle term, cancels out. So the bottom, what we in fact get is 10 plus 1. So here we go. 10 plus I square root of 10 over 10 plus 1, which is 11. And that is a simplified form of this quotient in a standard form. Now, why don't you try this guy? Good. So you said, well, just like the last example, number 3, we're going to multiply the conjugate of 6 plus I square root of 2. So that will be 6 minus I square root of 2. And whatever you do downstairs, you add 2 to the top. It's an identity property. And we're going to do the FOIL method for both top and the bottom. So in this case, 6 times 6, the first, is 36. 6 times negative I square root of 2 is negative 6I square root of 2. Now the inside terms, negative I square root of 2 times 6 is also negative 6I square root of 2. And negative I square root of 2 times negative I square root of 2, the last of the terms, it becomes positive I squared. And remember, square root times square root of 2 and square root of 2, the inside radicand comes out when you square a square root. That was a tongue twister. So that becomes actually just 2. Okay? Or, yeah, there it is. Okay? So now, over the bottom, 6 times 6 is 36. The outside terms, 6 times negative, well, you know what? We know the conjugate, the middle terms will cancel. So let's just go ahead and multiply the last of the terms. So positive and negative, I becomes negative I squared. And we just said for the numerator, square root of 2 and square root of 2, the tongue twister says if you square the square root of a 2, the radicand 2 comes out. So there it is, 2. Now let's simplify. Okay, the numerator 36, these are two identical binomials, so we're going to combine them to become negative 12 I square root of 2. So combining like terms. And since I squared is negative 1, this in fact becomes minus 2. Now the bottom. Right here also, since I squared is negative 1, here's what this says actually. So it becomes negative times negative 1 times 2. So it becomes just 2. So 36 plus the 2 now, which is 38. Okay, so when I combine the top even further, what we end up is 36 minus the 2, so it's 34 minus 12 I squared root of 2 over 38. Are we done? Not quite. The common denominator in this quotient, the common factor I mean, is 2. The 2 can reduce to 34 and 12 and 38. Let me write it to you this way. Since this is a 38 is a common denominator, I could write it as 34 over 38 minus 12I squared root of 2 over 38. Now I could reduce the quotients, the 34 and 38, common factor of 2, it becomes actually 17 over 19. Minus, common factor between 12 coefficient and 38 is also 2. So 2 reduces 12 6 times over 19 times here as well. So I guess our denominator stays common. So I'm going to write this as one single term as 17 minus 6I square root of 2 all over the 19. And that becomes the final simplified form of this quotient.